Hi guys, Mr. Lead here. Today we're continuing our topic of electricity by looking at series and parallel circuits. Okay, so what does that mean? What is a series and a parallel circuit? To explain this, I'll bring us to our good old friend FET here. So in this FET simulation, I've built a circuit with a light bulb, a battery, there's also an ammeter, we can ignore that for now. Now you'll see with this light bulb, I've just got one of them. If I want to add a second light bulb, there's two ways I could do this. The first way is I could literally just put in another light bulb here and then connect up the circuit. Now I've got two light bulbs. This is called a series circuit, all right? Now there's another way I could have added in a second light bulb. And here's one I prepared earlier. I could have added in like this, where I build a separate branch and I put in the light bulb in that separate branch, okay? So that's the difference between a series and a parallel circuit. Parallel, they're two different branches. Series, they're in a row. Before I continue, I'm going to just introduce a few other things in terms of how FET works, because you're going to use it quite a bit when getting familiar with electricity. When you click on the FET link, it'll bring you to these two options. You could either click Intro or Lab. Always click Lab. Just click Lab. Lab, the only difference between the two is Lab has a few extra components in it, so may as well always click Lab. When you're bringing out all the different components, it's always best to click Values so that you can see what measurements all your different components have. And the last thing I'll say with FET is light bulbs. People always stuff up light bulbs. If you see here, this light bulb is not a light, and there's one simple reason for that. Light bulbs have two little connectors here. So when you plug into both connectors, now the electrons flow through the light bulb when it's lighting up. All right, so there's a few things that people always get a little mixed up on. Another thing with FET is it's important to know how ammeters and voltmeters work. So ammeters measure current, voltmeters measure voltage. Ammeters, you can take an ammeter and you can plug it into the circuit just like this one is, or you can take this ammeter and you can hover it over and it tells you what the current is at that point in the circuit. Simple as that. Voltmeters, on the other hand, are what people get confused with. You see, with a voltmeter, you can't just plug one of these terminals, hover it over the circuit just like an ammeter, because it doesn't show anything. And you also can't point both of the terminals at the same point because, again, it doesn't show anything. See, measuring voltage is kind of like measuring the gradient of a line on a graph. Okay, so when you take a line on a graph, to measure the gradient, you need to take 2 points, and you find the difference between those 2 points. When you're measuring the voltage in a circuit, it's the same sort of thing. Voltage is a measure of the difference of energy between 2 points. So I need to put these two terminals on two opposite sides of an energy user, in this case, the light bulb. The light bulb is sucking away, I didn't mean to break that. The light bulb is sucking away energy, and I need to put the terminals on both sides. If you reverse the terminals, it'll show a negative reading. The only reason for that is because, the terminals are reversed and they're meant to, that's kind of just its way of saying it's meant to be the other way around. Cool. So that's how you use ammeters and voltmeters and FET. Now back to the topic of series and parallel circuits. So series circuits, this is where, like I said, the components are placed one after the other in a single loop. In a single circuit, there's only one path for the electrons to flow. Therefore, the current stays the same the whole way through the circuit, and if one of the energy users is broken, the entire circuit breaks. Okay, so looking back at FET here, I've got a series circuit. If I switch off this switch, it switches off both light bulbs. I can't find a way to switch on one at a time in a series circuit. And if one of the light bulbs was to, say, break, then both light bulbs go out. That's the disadvantage with a series circuit. And you also notice that the current in a series circuit is the same the whole way through. It's always 0.75 amps in this case. Now, here we have three little series circuits, all giving 6 volts of energy. But the difference is the amount of globes in each. This is what the globes would look like. Each of the globes get duller the more globes you put into a series circuit, because in a series circuit, the voltage is shared by all the components in the circuit. So that's the voltage here we're talking. The more components there are, the less voltage each of them receive. So so these light bulbs are way dimmer because they're having to share that voltage. We've got 6 volts being split across 3 light bulbs. That's 2 volts each. Okay, so that's the series circuit. With that knowledge, have a go at working out how many volts each of these light bulbs are receiving. And just assume they all have the same resistance. So for every single one of the light bulbs here pictured here, I want you to have a go at writing down what's the voltage they're each receiving. How much energy are they each getting? Pause the video. All right, I'm going to reveal the answers in 3, 2, 1. Here we go. Boom, there we go. So here, this one is getting 6 volts all to itself. Doesn't have to split it. Here we have 2. So we're having to split the 6 volts between 2 light globes. Splitting 6 volts between 4. Splitting 12 volts between 8. Hope you got those answers. Moving on. Okay. When it comes to resistance, the total resistance of a series circuit is just the sum of all the energy users and the resistance they each have. So if we had 3 resistors, this one has 1 resistance, 1 ohm, 2 ohms, 2 ohms. The total resistance here is what? Yeah, 5 ohms. Cool. All right, moving on. Parallel circuits. So in a parallel circuit, you have multiple branches. Here's the key difference between series and parallel circuits. Each branch gets a full voltage from the battery. The components do not need to share the voltage. So you'll see before when we had 2 light globes, each light globe had to get half the voltage each. Now, both of these light globes are getting 6 volts, the same amount that the battery is giving. This means that they can actually be brighter. And another good thing about parallel circuits is if one of these globes were to die, or if we had a switch here, we can affect one globe without affecting the other. So, there we go. I'll show this on FET. So, here we have our series circuit. I'm going to get out the voltmeter. No, sorry, parallel circuit. Here the voltage is 3 volts. And the voltage here is 3 volts as well. We can see the difference, even though these have the same resistance and the same energy supply. Look at the brightness of these globes. Each of these globes are getting 1.5 volts, whereas these guys are getting 3 volts each. It makes a difference in the functionality of the globe. And like I said before, if one globe was to die, it doesn't affect the other globe. So parallel circuits seem to be way better than series circuits. What's the trade-off here? What's the difference? The difference is the current. So if you look at the current at this spot, it's slower than it is at this spot. So it's pretty fast up here, 3 amps, but then when it starts splitting off, now instead of the voltage being split, the current is split. Okay, so go back to the slides. More specifically, in parallel circuits, each branch draws current that's proportional to its resistance. And the total current in the circuit is found by adding the current needed by each branch together. Okay, so what does that mean? So looking back at this circuit, if I was to actually remove these ammeters, you could actually work out the current using Ohm's law. So here we have, using Ohm's law, so triangle, we need to find current, so cover up the I, come on, there we go, cover up the I, it's V divided by R, voltage, 3 volts divided by 2 ohms of resistance. The current in this spot should be 1.5, right, and that's the same for both branches. If I was to increase the ohms a bit, that changes the current at this spot. So the current is always changed and it's proportional to whatever the resistance of that branch is. It's not like each branch is evenly split and each branch evenly gets the same amount of current. It's totally dependent on what's in that branch. Now, the total current, so the current back up the top next to the battery here, is just the sum of whatever current each of these branches have. So if I was to make it a bit more even again, so here we go. The current here is 1.5. Current here is 1.5. 1.5 plus 1.5 equals 3 amps. At the top here, it's 3 amps. So that's how you find out the total current of a circuit. All right. That's a little bit more confusing than splitting voltage in a series circuit, but have a go here at answering these questions. Assuming that each of these bulbs has a resistance of 2 ohms, every single bulb here, calculate the current in the branch, in each of these branches, and then deduce the total current flowing through the circuit. So assuming we had an ammeter up here, so assuming this is an ammeter, what is the current going to read at that ammeter? So I'm going to pause the video, and I want you to figure out the answers. Yep, all right. All right, so I'm going to reveal the answers in 3, 2, 1. Here we go. Okay, so using Ohm's law, we can work out the current of each of these branches. Like I said, you need Ohm's law to work out the current in each of these. So voltage divided by resistance gives you current. 6 volts divided by 2 ohms gets you 3 amps. So each branch should have 3 amps, and that should be the same for every single one of these branches. The total current at the top, though, is going to be 6 amps because that's just 3 amps plus 3 amps. And so the same here, we have 4 branches, each with 3 amps. The total current at the top will be 12 amps. And here it's 27 because it's 3 times 9. So, did you get that? Did you get all these as the answers? It's okay if you didn't. Remember, Ohm's law is a more handy tool than you would expect. Just to show these answers in full, I'll show them on FET. So here's the first one. As you can see, I've put in ammeters into these branches back again. So we've got a 6-volt battery, 3 amps for both of these, and then adding them up here is 6 amps. And here's the one with the 4 branches. So if I was to bring out my ammeter here, hovering it over, all of these branches are receiving 3 amps each. But if I was to climb up here, it's now 6 amps. Sorry. There we go. It's now 6 amps. Now it's 9 amps. Now it's 12 amps. So the voltage is like it's being added up as it goes back up the circuit. And it's losing it as it goes down the circuit on the sides here. Yeah, so up the top here, this is actually the most dangerous part of the circuit because the current is the fastest there. Yeah, so moving on, resistance. It was easy to calculate total resistance in a series circuit. You just added them up. In a parallel circuit, it doesn't work the same way. You can't calculate total resistance by adding these guys up. Good thing is that you don't need to work out that in year 9. You don't need to know how to calculate that. Okay, so summary. I want you to pause the video and see if you can fill in these gaps. Go for it. All right, I'm going to give the answers in 3, 2, 1. So in a series circuit, current is the same throughout the circuit. Voltage is split between components. Resistance for each component, the resistance of each component combines to give total resistance. In a parallel circuit, current of each branch is split proportionally to its resistance. Each branch gets the same voltage of the battery. Resistance for each branch does not add up to the total resistance. Okay, I should move this up here. So series circuits and parallel circuits are kind of opposites when you're talking about current and voltage, as you see here. All right, so that's series and parallel circuits. Thanks for watching.